In probability, I've found that the most difficult thing to work with is deciding whether to use the combination or the permutation, which is what we talked about in the last two videos. It is still difficult for me to choose which one is which, but if you think about them in this way, maybe it will help you out. Neither of them are allowed to have repetition, so combination and permutations, you can't repeat items for either one, combination or permutation. And the one that is helpful is that permutations are when the order matters. So if you're thinking about, when we talked about the mugs, once I put the first mug up, I can't put that one up as the second one, so that order is very important. Whereas when we talked about some of the other ones, like the wallets, didn't matter if the lady ordered wallet A and then wallet B, or wallet B and then wallet A, it just mattered whether she got A and B together at the same time. So we need to be careful there. If an item is repeating, then no matter what, you can't use either of these combinations or permutations. You got to go ahead and instead look at the fundamental counting principle. For instance, if I was looking at zip codes, or not zip codes, let's go with area codes because they're shorter. If we go with area codes from 1 up to 9, area codes have 3 digits. If I could repeat them, then that's fine. If I could repeat them, I have to go ahead and say, okay, I have 9 choices for the first one, 9 for the second one, and 9 for the third one, which would give me 9 times 9 times 9, which is 200, I don't know, 81 times 9, which isn't 200. Yeah, I think it is. Let's see. 729. So that's the number of ways for area codes from 1 to 9. If you're just using letters 1 to 9, you can't use a permutation or a combination like that because you would have 3 slots, choosing 3, and it wouldn't end up working out. So you can't use that if it repeats. Just go ahead and use fundamental counting principle. If it does repeat, then use combination or permutation. So we have the all-time dilemma of which one is which. We have a track team that has 6 runners in a race. The coach selects 2 runners to run in the first heat. How many ways can the runners be selected? And then we have an editor has 4 different spaces in a magazine to arrange his articles. He must choose from 6 articles. How many different arrangements are possible? Well, with our editor, we're going to go ahead and take a look and say that he has 4 different spaces in a magazine to arrange his articles. So he's got 6 and 4. On the top, we've got 6 and 2. With the coach, the track team, he's just trying to select some runners for his team. So we need to go ahead and decide if it's going to be permutations or combinations, and for the editor we need to figure out if it's permutations or combinations. And so if I'm looking at the track team, I want to use combinations for the track team, because if I had, let's call 2 people, let's say Eric and Johnny are 2 of the options. Well, if I have Johnny and Eric running, they're running in one single race, so this is the same combination. I can't choose this combination 2 ways. It's still Johnny and Eric running in the race, so I want to use 6C2 for a combination. And when I'm talking about the editor, he has 4 different spaces in the article. He has space 1, 2, 3, and 4. And he can mix them up if he puts, number 1 there, number 3, article number 3, article number 4, and then article number 6. It's going to be a different arrangement in his 4 different spaces if he then put 3, 1, 2, and 6 different arrangement. Even if I'd use the same numbers, it's totally different arrangement because there's 4 different slots. And there's 4 different slots for his article. It's like space number 1, space number 2, space number 3, space number 4. So it's kind of like if you were choosing first place, second place, third place, fourth place. So you're going to go ahead and use P, permutations for that one. You're going to have to just keep kind of working with it and checking your answers and seeing how it goes. And next week, when I get back on Monday, we can talk some more about combinations and permutations. I'm sure you'll have some questions, and I'll do my best to answer them as best as I can.